Alright, so this is chapter 1.5, problem number 3. It reads, you are buying a new computer. The table shows the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? Right? You are willing to pay the average price, the mean price, with an absolute deviation of at most $100. How many of the computer prices meet your condition? Well, first of all, we need to know the mean price. If you remember, that's just a fancy way of saying average. Alright, so add them all up. So I'm going to call this the price. And I'll put a little bar over it. Oftentimes a little bar over a variable means the average of whatever that is. So the average price equals, add them all up, divide by how many there are. Give me a second. The average P in this case equals 664. Okay, that's the average price. And if you want to know further about a mean, what it is, just Google it. Google how to find a mean. How to find mean. Or ask a friend. But that's the average price, that's the mean. And we want a standard deviation of at most $100. So, if we wanted to build an equation out of this, or an inequality, I should say, it would be the absolute value of the price minus my average price, 664. I mean, that's that midpoint. That's that average. Alright? And we want to be within $100 of it. So we need to be less than or equal to 100. And it says at most, so 100 is part of. If it says less than 100, well, then we need less than 100. But that would be our equation. Now, it's not asking you for an equation, but what it is asking you for is how many of these items right here are within $100 of 664. Well, that one's out. 664 minus 100. Nope, that one's out. 750, that's barely in. 3 out, 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 out. So, 2, 4, 6. There are 6 computers within $100 of the mean price. Okay? And that's how you do it. Letter B is very, very similar. Have at it. Letter C says to write an absolute value inequality that represents the situation. Alright? Then solve the inequality. Well, the difference between the perimeters of these figures is no greater than 10. Okay? Write an absolute value inequality that represents the situation. Then solve the inequality. The difference between the perimeters of the figures is no greater than 10. Well, we're going to call this, just for lack of a better term, we're going to call this one A, and we're going to call this one B. It says the difference in the perimeters is no greater than 10. So if I just take the first one and subtract the second one, okay, I want this to be no greater than 10. So I want it to be bigger than 10 or smaller than 10. I want it to be smaller than 10. So the absolute value of A minus B is less than or equal to 10. Now it can be 10, that's why I gave you the equal sign. We don't want it to be greater, but it can be 10. That's why I put the or equal to sign there. Okay? And we put the absolute values on there because if I do A minus B and get a positive, like positive 2, if I do B minus A, I get a negative 2. We don't care if that answer is negative or positive. We just want it to be within 10 units of each other. Okay? So now all I got to do is plug in the perimeter of A and the perimeter of B and solve for x. Okay? So the perimeter of A, well, how do you find the perimeter of a rectangle? Perimeter of a rectangle is twice base plus height. Whatever the base, it's 2 of the bases and 2 of the heights, so it's 2 of the bases times 2 of the height. So here we go. I got the absolute value of, we'll do A. A is 2x plus 1, 2 times 2x plus 1. I'm going to make my absolute value bar a little bit more distinct. Plus x plus 4. Close my parentheses. Then I want to do minus 2 times, do the other one. X is the height, plus x plus 3 is the base. Absolute value is less than or equal to 10. Alright? Just to kind of double clarify what's going on here, my A, that is the perimeter. It's 2 of these guys and 2 of these guys all added together. B is the other perimeter. So B, that's this one. 2 of these ones plus 2 of those ones. Right. And now we just distribute and solve and all that sort of stuff. So first things first, I'm going to clean up the middle because I don't want to have to clean it up twice. So if I do, let's start here. Let's combine terms. 2 times, that's what, 3x plus 5 minus 2 times 2x plus 3. Close the absolute value bar, less than or equal to 10. Then I'm going to distribute absolute value of 6x plus 10 minus, not 8, 4x plus, no, minus 6. Absolute value less than or equal to 10. Then I've got the absolute value of 2x plus 4. Less than or equal to 10. And now that's nice and clean. I can solve that twice. So let's go over here and do that. I've got 2x plus 4 less than or equal to 10. So that's 2x less than or equal to 6. X is less than or equal to 3. I also have 2x plus 4 is greater than or equal to negative 10. So that's 2x less than or equal to negative 14. X is greater than or equal to, divided by 2 is negative 7. So those are my two boundaries. And the way we're going to write it is, remember when we drew these out, we had a negative 7 and a positive 3? Well, the way we write this in one statement is we write this as negative 7 is less than or equal to x, is less than or equal to 3. Alright, and here's, let me clean this up, write it again. Alright, 2x greater than or equal to 14. So we had x less than or equal to 3, x greater than or equal to negative 7. When you graph this, we have a negative 7 and a positive 3 and everything in between it. And that is what this statement says. X is on the bigger side over here, so x is bigger than negative 7, but it's smaller than 3. It's on the smaller end here, so x is between negative 7 and 3. It's just a way to write that in a simple statement. Alright, try letter D. It's the same idea, but this time they're asking the difference between the areas. So just subtract the areas. How about it?